Exponents. I can apply the definition of exponents to simplify expressions. So we're not going to be solving for anything with these, right? That's kind of the key here. Simplify expressions. We're turning one thing into something that is somehow simpler. So what is the definition of an exponent? Well, if I have x to the n power, and usually n is actually going to be a number. And sometimes x will be too. But for now, I'm just saying, if I have something to some other power, that means x is called my base. So I have my base multiplied times itself n times. X to the n means x times x times x times x times x n times. Example, if I have x to the fifth, that would be 1, 2, 3, 4, 5. X times x times x times x times x. Now wouldn't you agree that this looks a lot simpler than this?
Yeah.
And this is why we use exponents. So we don't have to write out a ton of multiplication. We're just multiplying the same thing over and over and over. There's kind of some special cases. So if I have x, that is the same thing as x to what exponent?
1.
X to the 1. So x to the 1 is just x. Those are the same thing. But that means that if I see an exponent, or if I see a base with no exponent, I can add that in there if I want. I could say that x to the 5 equals x to the 1 times x to the 1 times x to the 1 5 times. If I wanted to. But it's simpler usually to leave out the one exponent and to just say x and know that that is x to the 1. Right? Here's a trick with exponents. Let's say I have negative x to the 4th power. You have to remember that technically this means negative 1 times x to the 4th power. Think back to your order of operations. What does the order of operations say? PEMDAS. The P is parentheses. What is the E? Exponents. So we're going to do the exponent before we multiply the negative 1 times that x. So negative x to the 4th power is the same thing as negative x times x times x times x. How many negatives are there?
1.
Just 1, right? How many x's? There's 4. So exponents with negatives can be a little tricky. Now sometimes you'll see something like this. If I have negative x to the 4th power, what's different from this to this? What's different between this here and this here? Both I would read as negative x to the 4th power. Negative x to the 4th power. But what do you notice as a difference?
It has parentheses
And where are the parentheses?
between the x and the 4.
Yeah, they're around this negative x. And so since I have parentheses around all of this, and the 4 is outside of those parentheses, that means this whole thing gets multiplied 4 times. So I have negative x times negative x times negative x times negative x. What do we get when we multiply a negative times a negative?
Bigger negative.
Multiply a negative times a negative. That equals?
Oh wait, no, a positive.
Yeah, that's going to be a positive. What do we get over here when we multiply a negative times a negative?
Positive.
So we just have a bunch of positives in the end. So negative x to the fourth is the same thing as x to the fourth. Huh. It's kind of interesting. All right. Now we could do this with numbers too, right? If I said 5 to the 7th, that would be written out as 5 times 5 times 5 times 5 times 5 times 5 times 5, 1, 2, 3, 4, 5, 6, 7 times, right? So generally, this would be considered the simpler form. And if I had negative 5 to the 7th power, that's going to be negative 5 times 5 times 5 times 5 times 5 times 5 times 5. 1, 2, 3, 4, 5, 6, 7, but only one negative. Right? The negative stays at the beginning. Alright. So we're going to talk about two rules today. Rule number 1 says this. X to the n times x to the m equals x to the n plus m. Let's look at why this happens. So if I have x to the 3rd power times x to the 2nd power, this rule says that's the same thing as x to the 3 plus 2 to the 5th power. And wouldn't you agree that this is a lot simpler than this? I went from 1, 2, 3, 4, 5 different symbols to just 2. So this is simpler. X to the 5th is x to the 3rd times x to the 2nd. But why is that true? Well, let's think about what x to the 3rd means. What does x to the 3rd mean? X times x times x. And what does x to the 2nd mean?
X times x.
Yeah, x times x. So now look, I have 1, 2, 3, 4, 5 x's, and they're all being multiplied together. Couldn't I call this x to the 5? Yeah, because that is x to the 5. So when I have the same bases, x and x, I can add the exponents. Same base, add your exponents. Let's do another example. So let's say I have z to the 4th times z to the 3rd. What would that equal?
Z to the 7th.
Z to the 7th. I just simply add those exponents together. How about if I have y to the 9th times y to the 10th? What would that one be?
Y t to the 19th power.
Y to the 19th power, 9 plus 10. What if I have negative x to the 4th times x to the 5th? What would that be? Negative x to the 4th times x to the 5th.
Negative x.
So remember what I said. this is my base, just the x, right? So the negative just sort of sits over here to the left, right? We're like, you could almost put like a bracket around this. Negative, right? Here's my negative. And then I have x to the fourth times x to the fifth, which is x to the what power?
What do you mean?
4, am I going to multiply these?
No, 9 power.
To the 9. So negative x to the fourth times x to the fifth is negative x to the 9th. Now what if I had something like this? Negative x to the fourth times negative x to the 7th. What would that be? Now my base is negative x. So I'm just looking at this as one thing. This whole parentheses negative x. So I'm going to leave that just like it is. Parentheses negative x. And then I look at my powers. 4 plus 7 is 11. So don't let these parentheses and negatives throw you off. This is the same thing as y to the fourth times y to the 7th. It's just instead of y, I have parentheses negative x, close parentheses. It's still something to the fourth power times something to the 7th power. Alright, let's take a look at some more examples. What if I have negative 5 to the fourth times negative 5 to the 7th? How would you simplify that? What's my base? This. Negative 5 in parentheses. I have the same base twice. It's raised to the fourth power here and the 7th power here, so what is my final power? My final exponent. 11. How did you get that?
Adding 7.
Yeah, 4 plus 7. Okay, what if I had this? 8 to the third times 8 to the 7th. What would that be? 8 to the 10th. Okay, now is it possible to simplify these further? Because I only have numbers? Yeah, technically I could find out what 8 times 8 10 times is. But for the purposes of what we're doing today, this is a final answer. Okay? 8 to the 10th. As long as I have one base and one power, I'm dead.
So we're not going into that?
We're not actually multiplying out 8 10 times. I know that you could do that. You probably use a calculator. Right? So I don't need to see you do that for the homework. I just need to know that you understand that this can be simplified by combining these exponents to make the 10.
So,
What if I had something like this? Negative 5 to the fourth times 5 to the third. What would that equal? Hold on, let's do this one and then I'll answer your question.
Negative 5 to the 7th power.
Yeah, and notice, since the negative is not in the parentheses, I don't include it. I just set it off to the side here. Yeah, what was your question?
on our homework, so, like, we're gonna be figuring out, like, so if on our homework, so, like, let's just look at 8 to the 10th there. The 8 to the third times 8 to the 7th equals 8 to the 10th. Are we gonna be, like, figuring out, like, how to get 8 to the 10th, or, like, are we gonna have that and try figuring out what 8 to the 10th
This would be your
is?
homework. It would say 8 to the third times 8 to the 7th. And your answer would be 8 to the 10th.
Okay.
We'll
And
just simplify this.
would we try, would it be okay for, like, okay, never mind.
If you think of it again, let me know. Alright, now there's another thing that's a little tricky with these. Let's say I had something like this. 2x to the fifth times 2x to the 5th. What is my base here? What is being raised to the 5th power? Yeah, only the x.
Okay, Max, I'd like to see that you're looking. Thank you. Okay.
So if I have other numbers here, I actually have to move this 2 over here before I can combine my x's. So I have 2 times 2, which gives me 4, x to the 5 plus 5, which is 10. So 2x to the 5th times 2x to the 5th is 4x to the 10. Do you guys understand how I got that? It's not 2x to the 10th. These 2's are separate from the x raised to the power. So if I had 3x to the 5th times 7x to the 3rd, what would I do? First I'm going to combine the 3 and the 7, but they're multiplied. These are multiplied. Those are coefficients. So 3 times 7 is 21. And then I combine the exponents by adding them, x to the 8. If you're ever confused, this is what you can do with exponents. 3x to the 5th. Okay, I'm just going to write that out. That means 3 and then x to the 5th is like this. 1, 2, 3, 4, 5. Okay? Times 7, and x to the 3rd is just like this. Now, wouldn't it be easier if I moved the 7 over here with this 3? That would be easier. So I could say 7 times 3, and then I have my x times x times x times x times x times x times x. 1, 2, 3, 4, 5, 6. Oops. I did one too many x's, didn't I? 1, 2, 3, 4, 5. No, I had the right. Had the right. 5. Yeah. That's the thing. And then I could count up. Okay, there's 8 x's, so that's x to the 8. They're all being multiplied together. And 7 times 3 is 21. So I have to keep my coefficients separate from my bases. 3x to the 5th. 3 is a coefficient. X is the base of that exponent. It only applies to the thing that it's right next to. And remember, this is because of PEMDAS. 3x means 3 times x. Exponents come before multiplication in PEMDAS. So x to the 5th happens before we multiply it times 3. Okay? All right. What if I had something like this? 3x times 2x to the 5th. What can you do with that? What can you do with 3x times 2x to the 5th?
Multiply 3 times 2 is 6.
Nice.
And then it's just,
Any luck, Max?
How did you get x to the 6th? That's totally correct.
because if there's just one x, that means it's x to the first power.
Yeah. this is the same thing as x to the 1. And then you did 1 plus 5 to get 6. Any questions on that one? That one's tricky. So should remember to take our two coefficients and multiply those. And then combine the 1 with the 5 to get 6. Alright. Now, anytime you have something in parentheses, that then becomes your base, right? So if I have 2x to the 4th times 2x to the 5th, now the whole 2x is my base. Do you guys see the difference from this to this? Here the parentheses are designating all of this is my base. And here I have no parentheses. So in this case, the base is going to still be 2x in the answer. And what will be my exponent for this one? 2x to the 4th times 2x to the 5th. It's going to be the final power here. I'm going to take the 4 and the 5. Should I just leave them? Ta-da! Oh, wait, that's the same thing I started with. What could I do? What could I do with those?
It could become
Yeah.
4x and 5 is least.
Okay, so in this case, I'm actually not going to multiply the 2's. Because they're not outside of the parentheses. I can't get at them. Right? So in the parentheses, I will keep my 2x. That is my base. My base is 2x. If this said y to the 4th times y to the 5th, what would you get?
You get y to the 9th.
Y to the 9th. But instead of y, erase all of your y's and write 2x in parentheses. What do we get? 2x to the 4th times 2x to the 5th equals 2x to the 9th. So my answer here is 2x to the 9th. Don't let these parentheses throw you off. This is the base. Alright, so I'm just going to leave it like that. Parentheses 2x. Sorry. Let's say I had 2x times 4x to the 7th. What would that be? So first I'm asking myself, are the coefficients part of the base? And they're not, because there are no parentheses around them. So I take my coefficients and I separate them out. 2 times 4 is 8. Now I ask myself, what exponents do I have? What exponent do I have here on the x?
It's 8x to the 8th.
Yeah, x to the 1 here. So 1 plus 7 is 8. So what if I have this? 3x times 5, actually 3x to the 3rd times 5x to the 3rd. What would that be? Are the coefficients part of the base? No, because they're not in parentheses. So I can just take those and separate them off. What is 3 times 5? 15. Now I have x to the third and x to the third, which becomes x to the,
6.
yeah, very good, x to the sixth. But what if I have this? 2x to the fifth times 2x to the seventh. Now, can I separate the 2 and the 2, those coefficients? No, I can't, because look, they're inside of these parentheses. So I can't pull them out because there's an exponent affecting everything inside these parentheses. So instead I just leave the 2x in the parentheses. That is my base. And now I add the 5 and the 7 to make, well, 2x to the 12th power. You guys see the difference from this to this? This one, the base is in parentheses, so the 2 can't be separated off. Right? It stays with my base. In this case, I have to get that 5 out of the way because it's not part of my base. All right. I think that's good for today. Questions on this?